In 2020, Toyota engineers tore down a Tesla and called it a work of art. Today, Tesla's next-generation production line is keeping the entire auto industry up at night. It cuts factory floor space by 50%, saves billions of dollars in capital expenditures, and allows a vehicle to roll off the production line at an unprecedentedly low cost. This isn't just a new manufacturing process, it's a knockout blow to the traditional auto industry. Tesla has finally completed its next-generation production line for its upcoming vehicle models, and the number of workers operating around the line has been almost completely eliminated. Essentially, the entire process has become fully automated.
The thing that's most interesting about this is it's a production system. It's a level of production technology that is far in advance of any automotive plant on Earth.
Elon Musk has emphasized that this would be a production system with a level of manufacturing technology far beyond that of any other auto factory in the world, allowing Tesla to build vehicles faster, cheaper, and with fewer defects. So, how does this production line actually work? Which models will it produce? And why is Elon Musk willing to invest so heavily in this technology? If you could watch the Cybercab production line running at Giga Texas, you'd immediately see why Elon Musk is so confident Tesla can eventually build millions of these vehicles every year. Honestly, it barely resembles a traditional car factory. It looks more like a machine designed to print money. The Cybercab may be Tesla's simplest vehicle, with more than 50% fewer parts than a Model 3, just 2 seats, no steering wheel, no pedals, and a massive amount of open space for luggage. But the production line Tesla built for it is anything but simple. In fact, it's unlike anything the company has ever put together before. Tesla isn't just taking its existing manufacturing playbook and adapting it to a new vehicle. They're changing the game entirely. That's a major reason the Cybercab can be built at such a low cost and why Tesla believes it can eventually produce millions of them every year at Giga Texas. It also explains why production is ramping up so quickly, even though this production line has only just begun operating. There's a massive contradiction here. Tesla's simplest vehicle requires the most ambitious, complex, and unconventional production line the company has ever built. But once you look at the bigger picture, it actually makes perfect sense. Tesla is exceptionally good at building expensive cars. What it hasn't really mastered is mass-producing truly affordable vehicles. The company has barely ever built anything that costs less than $35,000. So if Tesla simply took the Model 3 production line, swapped out a few machines, and started building Cybercabs, the overall cost wouldn't drop very much, even with far fewer parts. Elon Musk has also made it clear that Tesla doesn't want a simple vehicle like the Cybercab slowly moving through hundreds of individual production stations, following the same basic assembly process the auto industry has relied on for more than a century. That approach simply isn't efficient enough. Instead, Musk says Tesla has been working toward a manufacturing system that goes far beyond anything currently used in the automotive industry, all to make one specific vehicle as efficiently and cheaply as possible. At Tesla's Texas factory, the Model Y production process starts with hundreds of individual metal panels. Those panels are stamped, transported to the welding area, and joined together to create the vehicle's body structure. From there, the body moves through the paint shop, gets dried, and then enters a final assembly line that stretches for miles. At that point, the Model Y is basically just an empty shell. As it moves down the line, workers and machines gradually add the wiring harness, air conditioning system, windows, carpeting, seats, dashboard, doors, steering wheel, braking system, and hundreds of other components. Every vehicle has to follow roughly the same sequence, with each station completing its job before the next one can take over. It's a highly organized and proven system, but there's one major problem. If even a single station runs into an issue, the disruption can ripple through the entire production line and slow everything down. A welding robot going down, a component arriving late, or even a single electrical connection that refuses to fit properly can create a bottleneck. And when you're building hundreds of thousands of vehicles every year, losing just a few seconds at each station can quickly turn into thousands of hours of wasted production time across the factory. Tesla knows this problem better than most. The company experienced what Elon Musk famously called production hell during the Model 3 ramp-up. Back then, Musk believed extreme automation could solve nearly every manufacturing problem, but reality had other plans. Tesla eventually had to remove some of the machines, put people back into parts of the production process, and completely rethink the system, all while racing against intense production pressure. Now the Cybercab gives Tesla something it rarely gets, a chance to start from scratch. Instead of sending the entire vehicle down one massive assembly line and installing every component step by step, Tesla wants to divide the Cybercab into large modules that can be built simultaneously and then brought together later. The front section could be built in one area, while the rear section is assembled somewhere else. The doors, exterior body panels, floor, battery pack, seats, and interior could each be handled on their own branches of the production system. Once those modules are finished, they would converge at a central area where everything comes together to create a complete Cybercab. You may have heard of Tesla's Unboxed Process since we've covered it in some of our previous videos, but this time we're going to look much more closely at how the system actually works and why it matters so much. Because the Cybercab relies heavily on this unboxed process. With this approach, major sections of the vehicle stay open and easily accessible throughout much of the manufacturing process. Robots and workers can reach components from multiple directions instead of being forced to work around a nearly finished vehicle. Seats can be mounted directly onto the floor before the upper body is closed, while wiring can be installed while each module is still open and easy to access. The exterior body panels don't have to be installed early in the process either, where they could get scratched, dented, or damaged during dozens of assembly steps that follow. A simple way to think about it is this. Instead of constructing an entire house from the foundation to the roof in one continuous process, you build each room separately and only bring everything together at the end. In theory, that could dramatically reduce the amount of factory floor space Tesla needs, shorten the distance components have to travel, and allow multiple manufacturing processes to happen simultaneously. And there's another major advantage. If one branch of the production system hits a problem, the other branches can keep running for a while instead of forcing the entire factory to stop immediately. But this is also exactly where the Cybercab production system becomes incredibly challenging to execute. Building each module on its own isn't the difficult part. The real challenge is making sure every module reaches the integration point at exactly the right moment, in exactly the right position, with tolerances that are measured in tiny fractions of a millimeter. That's why, even though Tesla first introduced the concept in 2023, the company didn't reach roughly 70% completion of the production line until 2026. For more than 3 years, Tesla has been working out the exact speeds, timing ratios, and millimeter-level tolerances required to keep every module moving through the system correctly. And even now, the system still isn't completely finished. That's one of the reasons Cybercab production hasn't ramped up as quickly as many people expected. At this point, it's no longer just a car manufacturing challenge. It's a massive synchronization problem involving thousands of robots, sensors, controllers, and transportation systems, all of them having to work together with the precision of a gigantic mechanical clock. Tesla is betting that once fully operational, this system can move faster than any traditional automotive assembly line. And the Cybercab was designed from day one specifically to take advantage of it. With only 2 seats, the cabin is much simpler. No steering wheel or pedals means Tesla can eliminate a large amount of mechanical hardware around the driver's position. There's no traditional instrument cluster either, allowing for a simpler dashboard. Fewer buttons, fewer wires, and fewer moving parts ultimately mean fewer steps on the production line. And to make the next generation production line more productive, Elon Musk has suggested that the company could eventually develop a 50,000-ton Giga Press, far larger than the 6,000 and 9,000-ton machines already used in large-scale vehicle production. The idea immediately raises several questions. How could a machine of this enormous size be built and installed? Where could Tesla place it inside a factory? While these questions sound futuristic, Musk's vision is based on expanding technology Tesla already uses rather than completely reinventing the casting process. The biggest difference would be scale and speed. 50,000-ton Giga Press could operate as part of an extremely fast, highly automated production system. Instead of relying heavily on human workers moving between different manufacturing stages, robots and machines would coordinate the entire process. Molten aluminum would be injected into a mold, allowed to solidify, removed, cooled, inspected, and prepared for the next cycle with minimal interruption. Each casting cycle could potentially take only a few seconds, making the production line resemble a high-speed electronics factory more than a traditional automobile assembly plant. The metal is heated to approximately 850 degrees Celsius in a primary furnace until it becomes completely molten. After impurities are removed, the liquid aluminum is transferred through heated pipelines into a second holding furnace. This furnace maintains the aluminum at roughly 750 to 850 degrees Celsius, ensuring that it remains ready for injection whenever the next casting cycle begins. Tesla's dual furnace approach also helps maintain material quality. The primary furnace can use natural gas to melt the aluminum, while the holding furnace can be electrically heated. A high-speed piston pushes the aluminum into the mold cavity under enormous pressure. Once inside, the metal quickly takes the shape of the mold and begins to solidify. The newly formed component can still be extremely hot, reaching nearly 400 degrees Celsius when it leaves the mold. The casting is immediately transferred to a cooling system where its temperature can drop to approximately 50 degrees Celsius. Rapid cooling helps shorten production time while also improving certain mechanical properties and reducing potential casting defects. Meanwhile, the mold is cooled to around 185 degrees Celsius and cleaned by robotic systems so that it can be used again. Any excess aluminum is trimmed from the finished component and recycled back into the melting process. Before the part is approved, Tesla can use X-ray inspection to check for hidden internal defects and verify structural integrity. However, one of the greatest engineering challenges is the enormous clamping force required during injection. Molten aluminum is forced into a sealed mold at extremely high pressure. Without sufficient force holding the mold halves together, the mold could separate and ruin the casting. A 50,000-ton press would therefore require an extraordinary clamping system. Ultimately, Tesla is also taking a completely different approach to the way the Cybercab's exterior is produced. Even the vehicle's wiring architecture is being developed around the unique requirements of this robotaxi. And there's no denying that the Cybercab's yellow exterior is designed to grab your attention. Whether you see one during the day or at night, it's almost impossible to mistake it for another vehicle. The first prototypes revealed earlier this year wore a matte yellow finish, but the production Cybercab has taken a different direction, using a much brighter, glossy yellow. Tesla isn't simply painting that yellow onto the Cybercab the way it does with vehicles like the Model Y and Model 3. The color is actually incorporated into the exterior material during the molding process itself. That's where reaction injection molding, better known as RIM, comes into play. If Tesla can make this technology work at scale, it could remove a significant portion of the conventional paint process from the Cybercab factory, and that matters more than you might think. In a traditional car factory, the paint shop is one of the biggest headaches. It's expensive to build, consumes huge amounts of energy, and requires an incredibly controlled environment. Once a welded body enters the paint process, it has to pass through a long chain of treatments. Cleaning, surface preparation, corrosion protection, primer, base coat, clear coat, and finally high-temperature curing ovens. Every stage adds time, equipment, energy consumption, and another opportunity for something to go wrong. The environment also has to be carefully controlled for airflow, filtration, dust, chemicals, and temperature. And when the finish is supposed to look perfect, even a tiny particle of dust landing on the surface at the wrong moment can be enough to send an entire panel back for rework. These are some of the new technologies being incorporated into Tesla's next-generation production line that Tesla has never done before. In the next episode, we'll discuss this line in more detail. What do you think of Tesla's innovation in car manufacturing? Is Tesla changing the automotive industry? That's all for today's deep dive into Tesla's engineering. If you enjoy exploring the technology behind the world's most advanced factories, hit that like button and subscribe. There's a lot more innovation waiting ahead.